Hey, what's up, everybody? Happy Friday if you're watching this today. Welcome to another episode of X-Ray with Mr. Gray. It's Friday here, payday. Rainy morning so far, so it's gonna be a nice day, I hope. So, wanted to get on here for a specific student had mentioned this in one of her videos. Miss Ashley, this is for you and for everybody else. My students, if you're waiting for your state exam, watch this. This will help you too. So, I'm gonna get on here and talk a little bit about dose response. Threshold, non-threshold, stochastic, deterministic, all those fun things. So, I have my dose response chart here. We have the dose and we have the response. So we're gonna talk about basics of a dose response chart, the difference between linear, non-linear, threshold, non-threshold. Threshold, non-threshold also means stochastic, deterministic. So keep those straight too. So if something is a threshold dose, that means it has to have a certain dose. You have to pass a line of a certain dose before any type of biological response would be expected. That doesn't mean that it's going to happen. Biological effects are mostly random, probabilistic. Most of them are what we call stochastic or non-threshold, meaning any dose could potentially be dangerous for you. When we talk about a threshold or a deterministic dose level, so threshold means we have crossed that line, we have crossed that threshold to where now the chances of response happening are greater. Deterministic means the same thing. It means basically we have determined at this level of exposure, this will be expected to happen. So the way I, with my class, and if you were just on my live, you heard this, talk about dose response models, is I relate them to the F around and find out video that we've all seen on TikTok and on social media. So the more you F around, the greater the chances of finding out, right? So that's what I like to describe as a linear stochastic response or a non-threshold. So that basically means that stochastic, again, is going to mean that any dose could potentially have an effect. Does that mean that the dose is going to definitely cause cancer? No. Is there a chance? Very slight chance, yes. But we have to say that with any radiation dose, there is a chance of a response. And as that dose increases, the probability of a response also increases. So that is a linear relationship, meaning starting at any dose, that line continues straight up. So this is your dose, this is your response. This is your F around. This is your find out. Okay? I know my board writing is horrific. So basically, the more dose you receive, the greater the likelihood of response happening. Do we know that there's a set level with which a response is going to have? Yeah, for some things we do. For cancers, no. For cancers, they're all probabilistic. They're all random. So what we say is that the more dose you receive, the more likelihood of a response happening. And if that likelihood is proportional, then it is linear, meaning as the dose increases, the likelihood or the chance of something happening also increases proportionately. The more you're effing around, the greater the chance that you're going to find out. Okay, so that would be non-threshold linear response. Now, let's take off our linear response here, and let's talk about a nonlinear response. Nonlinear response means that at a low enough level, we don't expect anything to happen, but at some point, the chance of that response becomes greater. So, relating it back to the other model, I'm gonna let you F around with me a little bit. Like, you can take your shots, but there's gonna come a point to where you're gonna cross a line and they're gonna be like, that's a little too much. Now your chances of finding out are starting to increase. So that's nonlinear. It is not directly proportional. The more dose doesn't always mean the more chance of it happening. Depends on the type of response, okay? So those are both stochastic or non-threshold doses. So linear and nonlinear always stays the same. It's either directly proportional to the dose or it's not directly proportional, meaning it's a curvy line, or what they call a curvilinear, or sometimes it's called a sigmoid curve. Threshold or deterministic means that we have determined a set amount of radiation can definitely cause this. So some of the ones we talk about are skin erythema, epilation, temporary sterility in males, cataracts are a threshold response model. Most things we deal with, most of our radiation protection guidelines are based on a stochastic linear, meaning any dose could cause a response. But there are some things that we know, once you reach a certain dose, this is expected to happen. So with me, with my cancer treatment, I knew at some point I was gonna have erythema to my throat and my neck. I knew I was gonna have epilation, I was gonna lose some hair. I was gonna have desquamation, which the skin started peeling and was all black and just looked really gross. So I had to reach a certain level of radiation before that happened. So that means a threshold. So from here to here, we expect nothing to happen. There should not be any epilation. There should not be any skin erythema. There should not be any desquamation. There should not be cataracts. When you reach a certain dose, that's when it's like, uh-oh, okay, now you reach this dose, now the likelihood of this is more possible. So that's basically the difference between threshold and non-threshold, which also means the same as stochastic and deterministic. Don't get those terms confused. They do basically mean the same thing. Linear, non-linear. Linear, the chances, as the dose increases, the chance of a response directly increases. Nice straight line. Non-linear means that there's a certain level at which we can expect a response to happen. After this amount of dose, this might start happening. We still can't say for sure it will because it's not a threshold. It's not a deterministic dose. All right, so I hope that helps a little bit. Hope that made it a little bit clearer for all of you. Ashley, I hope that helps you a little bit. If y'all have specific questions, reach out to me and let me know. But hey, have a great weekend, everybody. Thanks for tuning in, and I appreciate all the love y'all send. Sending it right back. Y'all have a great day today. Stay strong. We'll see you next time.